Hello students, today we are going to start with the concept of increasing function and decreasing function. I would like to teach you first of all the definition, what is an increasing function, right? First of all, when you have to check the function is increasing or decreasing, there are two methods. One is without using derivative, the other one is with derivatives. If you are finding without using the derivatives, we will say a function f is said to be increasing. This is a symbol. If you put the arrow upward like this, if you put the arrow upward like this is a symbol for increasing on an interval which is open here, a to b. If any two numbers x1 and x2 which lies in AB are such that x1 is less than x2, that means you are picking two numbers lying between A and B such that x1 is smaller than x2, which implies f of x1 is less than equal to f of x2. That means if you pick two numbers, suppose this is given as 4 and this is given as 7, so you may pick two numbers 5 and 6. If you put those two values of 5 and 6 in the given function f which will be provided to you, and f of 5 is coming less than or equal to f of 6, then we say function is increasing, right? This is the method without using derivatives. But if you have to use the derivatives, how you will do it? A function f is said to be increasing on open interval AB if f dash x greater than equal to 0 for all x belonging to AB. What does it mean? Whatever function is provided to you, you will find the derivative of the function, and at that particular value, if the function is greater than equal to 0 for any x that you pick up for between a and b, lying between a and b, if you pick up any value of x and that gives you f dash x greater than equal to 0, then you call it as a increasing function. Fine. Same way for decreasing function without using derivatives. A function fx is said to be decreasing. If you put the arrow downward this way, this is a symbol for decreasing function on open interval AB. If x1 less than x2 in AB, that means 2 points from AB which are x1 and x2 such that x1 is less than x2, gives you f of x1 is greater than equal to f of x2. That means the numbers are in such a way that x1 is less than x2. Then these numbers, if you substitute in the function, they give you the reverse sign. F of x1 is greater than or equal to f of x2 for all x1, x2 belonging to AB. Then we call it as a decreasing function. Or if you have to use the derivative, then same way you will be proceeding. You will be finding f dash x. If f dash x is less than equal to 0 for all x lying between a and b, then we call it as a decreasing function. Then comes the concept of strictly increasing or strictly decreasing. There's a difference. Here we have used the concept only increasing function or decreasing function, but then comes the concept of strictly increasing or strictly decreasing. As it is clear from the name, strictly means there will not be any symbol of equal to. So strictly increasing function means if x1 x2 less than x1 is less than x2 in open interval AB, then f of x1 will be less than f of x2. Rest of the definition will remain same, but equality sign will not come, right? And same way here, when you will find the derivative, it will be f dash x will be only greater than equal to 0. Sorry, f dash x will be greater than 0. Equal to the sign will not occur. Decreasing function, if x1 is less than x2, then f of x1 will be greater than f of x2. Then we call it as strictly decreasing function. If f dash x will be less than 0, then we call it as strictly decreasing function. I hope it is clear what is increasing function, what is decreasing function. Normally in the question, if it is asked, it will be asked maximum of 1 mark. One function will be provided to you. You need to check whether the function is increasing or the function is decreasing. Fine. Before I start ahead, because sometimes in the question it is asked, they ask you about the intervals in which the function is increasing or decreasing. I'll teach you the method for the same. Before that, I would like to teach you about the critical points. Which points are known as the critical points, right? To find the critical points, we need to check the derivative of the function, whatever is given to you, and then you will find out the derivative which is given equal to 0. First of all, you will find the derivative, then you will equate the derivative to 0. So whatever values of x you will get in that case, that is known as the critical point. Fine. So suppose one example we can quote here. If fx is given equal to 3x square, then f dash x will become 6x. When you will put 6x equal to 0, only one value of x will occur, that will be x is equal to 0, and that is known as the critical point. Now I am going to teach you method how to find the intervals in which a function is strictly increasing or strictly decreasing. Step 1. You will be finding f dash x and then equate to 0 to get the critical points. As I told you just now, first you have to find the derivative, equate the derivative to 0. The values of x that you will obtain are known as the critical points and in the given interval AB, right? If the interval is not provided to you in the question, then you are going to consider the interval minus infinity to infinity, which is known as a real number line. Again I repeat, first of all you will find your derivative of the function, equate that derivative equal to 0, that will give you critical points. It will be those critical points, obviously if the interval is given, they will lie in that interval, or you will consider minus infinity to infinity if interval is not provided. Then step 2, you have to arrange critical points in ascending order. Whatever points you are getting, maybe negative, maybe positive, maybe fraction, you are going to arrange them in an ascending order. Suppose you have x1, x2, x3 up to xn, n critical points are there, such that if you arrange them in ascending order, it will become x1 less than x2 less than x3, so on less than xn. Then step 3, you will check the sign of f dash x by making semi-intervals. How to make the semi-interval? Suppose all these points x1, x2, xn, they lie in the open interval AB. So obviously these points are lying in between here A and B. So you're going to split them into the semi-intervals A, x1, then x1, x2, then x2, x3 and so on, and last one will become xn B. After making the semi-intervals, you will substitute picking up one value from here. From a to x1, one number lying between a to x1, you will substitute in f dash x. If that is coming greater than 0, it means the function is strictly increasing. If that is coming less than 0, that means function is strictly decreasing. As I told you in the definition, when you have to use the derivative, if f dash x is greater than 0, that is for strictly increasing. If f dash x is less than 0, that is for strictly decreasing. Again I repeat, first of all you will put f dash x is equal to 0 to get the critical points. Whatever critical points you will get, you will arrange them in the ascending order. Then you will arrange semi-intervals. After making the semi-intervals, one by one from the semi-interval, one value you will pick and put in f dash x. Wherever it is becoming greater than 0, that is for strictly increasing. Wherever it is less than 0, that is for strictly decreasing. Now on the basis of this, I would like to do questions for you so that the concept is more clear to you. I am starting with exercise 6.2. It says, first question, fx is equal to sin x. Fine. You are going to check intervals are provided in A, B and C part where the function is increasing, where the function is decreasing. As I told you, the first step is to find the derivative, right? If the points interval is not given, then we will find out the critical points. But when it is given here, we are not going to find out because it is told to check specifically for this interval only. So f dash x is cos x. In first part, your open interval is provided as 0 to pi by 2. So f dash x, since we know 0 to pi by 2, this is your first quadrant. As this is 0, this is pi by 2, this is pi. So 0 to pi by 2 is the first quadrant where all t ratios are positive. So f dash x is positive here, which is cos x. It is positive here, hence we can say fx is strictly increasing in this open interval. When x belongs to pi by 2 to pi, that means it will become the second quadrant. So f dash x is less than 0 here, as cos x is negative in second quadrant, right? Because here we know cos x is negative. So we say fx is strictly decreasing in this second interval. Now they are asking from 0 to pi. We know one thing, in first part we said 0 to pi by 2, this function is increasing. in pi by 2 to pi, this function is decreasing. So collectively, what can we say? It's halfway increasing, halfway decreasing. That means we will say, we cannot say particularly about increasing or decreasing in this interval 0 to pi. So we will say it is neither increasing nor decreasing in the interval 0 to pi. Right? Now I'll teach you the question related to how to find the semi-intervals or the intervals where the function is increasing or decreasing, for which I have told you how to find the intervals for the same. Here function fx is provided as 2x cube minus 3x square minus 36x plus 7. We'll find out the derivative here. It will be 6x square minus 6x minus 36. First step, since no interval is mentioned here, we are supposed to find the interval. So we will find the critical points first. Put f dash x is equal to 0. So from these three, you can take out 6 common. By splitting the middle term, you are getting these two critical points. One is 3, the other one is minus 2. Since no interval is mentioned, we are going to consider as minus infinity to infinity as a number line. Minus infinity here, infinity here. Points are 3 and minus 2. Obviously on the number line, minus 2 will lie first and 3 will lie later. So we have 3 semi-intervals here. Minus infinity to minus 2, minus 2 to 3 and 3 to infinity. 3 intervals are there, right? When we pick up any value from minus infinity to minus 2, so we know from, if minus 2 is here, then after that we have minus 1, then 0. That means here we can pick up any value, minus 3, minus 4, minus 5, any value we can pick up. And that value we will substitute in f dash x, right? F dash x is here, which we can write here after taking out 6 common. X square minus 6 is equal to 0, or we can make the whatever factors we have made, we can write it here. This was your f dash x, right? So I'm going to put the value. Suppose I pick up minus 4. If I put minus 4 here, it is minus 4 minus 3. If I put minus 4 here, minus 4 plus 2, it will give you negative sign. No need to solve it, and it will also give you negative sign. 6 was positive, right? So you have negative and negative. Ultimately it will become positive. Hence you will say f dash x is greater than 0. So it is strictly increasing in minus infinity to minus 2. Why we say strictly? Because it is greater than 0, not equal to 0. Now in the next interval, minus 2 to 3, you may pick up any value. There are so many values, minus 1, 0, 1, 2. So any value. Suppose I am picking up value 2. This 2 I am going to substitute here. If I put 2 minus 3, it will give you negative sign. If I put 2 and 2 here, it will give you positive sign. So here I am writing negative, positive. Ultimately minus plus is minus, it is less than 0. Hence it is strictly decreasing in this interval. Now last one is 3 to infinity. Any positive value you may pick up. Suppose you pick up 10. If you put 10 here, 10 minus 3, 10 plus 2. Both are giving positive answer. Hence it will be greater than 0. So it is strictly increasing in 3 to infinity. So what we have found here, in this interval and in this interval, in both intervals it's strictly increasing, and in this interval it is strictly decreasing. So we will combine this one here. That will say fx is strictly increasing in minus infinity to minus 2 union with 3 to infinity, and fx is strictly decreasing in minus 2 to 3. So on the basis of this, you can easily complete exercise 6.2, all the questions. If you have any doubt or any query, you may ask. Thank you and have a nice day.